and share screen. Okay, can you see it, guys?
Yes, we can.
Okay. So question 1, we're given this data. And if you read the question, it says to use goodness of fit. So it's easy. We just go to straight goodness of fit.
السلام عليكم.
عليكم السلام.
بدينا وين chapter 11
We're doing the review test first.
نزلت review test
Yes.
يلا نزين.
Okay. So first, let's do the hypothesis. So over here, we have the claim, okay? So whether the distribution of the variables differs from the given distribution or not. So this one is wrong. And then we have these two. So H0, the null, it's always going to be the same. So this one's going to be wrong. Yeah, so it's D. So we open the data and StatCrunch. We'll go to goodness of fit and chi-square. We don't use normality or outlier. So observed is going to be the frequency, so var1. And the distribution is the expected distribution that we have to use. So here we have the chi-square. Going to copy and paste. And 3 decimals. So this will become 2. So next we have to find the critical value. So what we'll do is go to stat, calculators, and then chi-square. So we'll go to the right side, and we have degrees of freedom right here, 3. And next, we'll put the alpha, 0.05. So this is our chi-square,
هذا
the critical value.
this is
Yeah.
for the critical value. This is part of chapter 11, I think, or was it 12?
Yeah.
I don't remember.
It's
Okay.
chapter 11, 11.1.
Okay, so stats, what did you say? Stat calculator?
Yeah, stat, calculators, and then chi-square.
Chi-squared, okay.
Yeah, and then we take the right side, and then we put degrees of freedom that we have here, and then we'll put alpha over here, and then we compute. And this is our critical value, copied and paste. So we'll do the last part now. So does the data provide sufficient evidence that the distribution of the variable differs from the given distribution? So our test statistic is less than the critical value, so we fail to reject the null hypothesis. So the variable is going to be the same as the given distribution. So is it different? No, because we don't have sufficient evidence to reject. So A.
No, هي تعتبر filter reject.
So right here it says, yeah, do you have evidence that the variable differs from the given distribution? So we couldn't reject the null hypothesis, which says that they are the same. So
Okay,
no,
so
it's not different. Yeah. So no,
so
it's not different
the
because
test,
we didn't.
when the test statistic is lower than the critical value, it's filter reject.
Yes. And if
Okay.
it's more than, we're gonna reject.
Reject.
Yes.
Okay.
So here's question 1. We finished with it. Go next. Question 2. So here we have to use chi-square goodness of fit test to decide whether, this is our claim, the color distribution differs from the reported distribution. So this is different from the claim. So these are automatically wrong. So we have to choose one of these. So we said the null is always the same. So this one is
C?
wrong. Yeah, so it's C. So we will open the table in StatCrunch. And then we go to goodness of fit, chi-square. So the observed is the frequency, and the percentage, it's what we're expecting.
Mahmoud, how would I know which one is going to be the observed and which one is expected?
Does here look. So a certain type of candy is reported to be distributed with the color percentage down below. So the
Okay.
frequency is what they counted, and the percentage, it's what the company claims. Like 16% is going to be green, 20% going to be orange, and so on.
So the percentage is, I think the expected, you said, or
Yeah,
the...
yeah, it's what we're expecting.
Okay, can you just do the edit so I can see the...
Yeah. So here, when you see a reported distribution, it means
Yes.
that there's an expectation. And then if it says that they're all the same with the same frequency, then we'll do all cells are
Uh,
equal.
Observed
Yeah,
frequency expected is in
yeah.
percentage.
So since we're given reported distribution, it's the expected distribution. And the
Oh, okay.
frequency is what we counted.
Okay, thank you.
No problem. So observed frequency, expected percentage. So we'll compute. We have chi-square. So here, test statistic, we're going to paste. We have 3 decimals. So we'll round up. Next is the critical value. So stat, calculators, chi-square. Remember to do the right side, and then 5 degrees of freedom. And then we have to see the alpha, 0.05. We'll put 0.05 and we'll compute. So this is our test statistic, our critical value. So we'll put 3 decimals, 4, so we're not going to round up. Now compare the test statistic with the critical value, or you can compare the p-value with the alpha. So whatever one that is easier to you, you can use. So p-value is less than alpha, so we're gonna reject the null hypothesis. So what does the null hypothesis say? That they are the same. So we rejected it. That means the color distribution is different. So here, does the data provide sufficient evidence to conclude that the color distribution differs from the reported distribution? So we rejected the null hypothesis, so yes. Okay, so shall we go next?
Yes, sure.
Okay. Okay, so here we have an observed frequency. So this is our category of the die. So we have like side 1, side 2, 3, 4, up to 6. And for each one, we have a frequency. Okay.
Is this the one where we have to put it in manually?
In this review test, it's automatically there, so you don't
This
have to.
review, it does it. Okay, because before it made us input it.
Yeah, so here it does it for you, so you don't have to worry about that. So here it says the claim that the outcomes are not equally likely, right? It doesn't give you a reported distribution, it doesn't give you an expectation. So what we're gonna do is stat, goodness of fit, chi-square. So we'll pick frequency for the observed, and since we don't have a given reported distribution, and we're testing for if they're equally likely or not. So we'll do all cells equal. So what is our hypothesis? So these are not the same as our claim, so we're gonna ignore them. So here we have to choose one of these. So
D.
yeah, it's D, yes. As we said,
It's always if it's the H0 is the same or equal, it's the right one.
yes.
But the claim said it's not equally likely.
Yeah, so H0, it's always gonna be equal. So regardless of the claim, it's gonna be always equal for the null hypothesis. And H, the alternative, is gonna be the option that is the opposite of the equality. So at least one is going to be different. So H1 is going to be the same as the claim, and H0 is always equal. So if you're doing the review test, if H0 does not have equality, it's automatically wrong, because we always test for equality with the null hypothesis. So let's do the calculation again. So goodness fit chi-square. We took frequency for the observed, and we took authors in equal proportion. So we have our chi-square. That's our test statistic. We're gonna put 2 decimal places. So this will become 9. And next we have to find the critical value. So stat calculators, chi-square. We'll go to the right side, and we have 5 degrees of freedom. And the significance level is 0.05. So we'll copy this and we'll put 2 decimals.
This one is reject, I think, yes?
Yeah, so test statistic is larger than critical value, so we reject. And also we have the p-value less than alpha, so it's the same. We reject. So we rejected that they are equal. So do they behave differently? Yes, because we rejected the null hypothesis.
I have a question.
Yes.
Like there will be always one tail, like critical value is one, so it is always one tail, right?
Yes, because the chi-square, we don't have a negative critical value. And for
Okay.
the f-stat, we don't have a negative. So we only have one critical value.
Okay, so it will
And
be
it's
never two tail.
positive. Yeah, so you only have one to the right tail, and it's positive.
Okay, thank you.
Welcome. So we're done with this. We'll go next. So let's close this. So here we have a contingency table, and we have to find the expected frequencies. So we'll open in StatCrunch. We'll go to Stat, Tables, Contingency, Summary. So in the column part, we'll choose the var2 and var3, where we have the numbers, the data. And for row, we have labels A, B. And since we're looking for the expected frequency, we'll click this one, expected count, and then compute. So right here, we have the expected part. So we'll copy and
How
paste.
do you select more than one option? Was it like shift or to select two things?
You can just click on var1 and then hold and scroll down with your mouse.
Oh, okay. Then you said the rows var1, it's A and B.
Yeah.
And the
So,
display, it will always be, it will have expected count in these types of questions.
Depends. If it asked for the expected count, you have to click here and then compute.
Or if it can ask for something else, I think. Yeah.
I don't think it's gonna ask you for anything else except expected count.
Oh, okay. That's my question. That is always going to have the expected count in this question.
Yeah. So
Okay. Thank you.
you're welcome. So we'll put the expected count here. So 3 and 20. So the test statistic is value. We'll copy it. And we have to do 2 decimals. So this will become 7. So when we're testing for contingency, we're testing if the variables are independent or not. So the two variables, so if they're associated, that means they're dependent. If they're not associated, they're independent. And H0 is always going to be independent. So not associated. B.
Not associated is independent.
Yes. And associated means dependent.
Ah, okay. We want the independent one, yes?
Yeah, so H0, the
Where
null,
does it say in the question it wants the independent?
if it's contingency table, it tests for independence.
There another table for dependence?
No, you just test
Ah.
for independence. That's it.
Okay.
So critical value. So we're using chi-square, so we'll go to stat, calculators, chi-square. So we'll go to the right side. We have 1 degree of freedom. And here, the significance level is 0.05. Copy and paste 3 decimals.
By the way, in the calculator, do you have the option standard or between?
It's, I think, standard, because between is something else.
We don't change it, yes?
Yeah, keep it on standard.
Okay.
It's automatically on standard, so you don't have to do anything. So we put 1 degree of freedom, and we put the alpha here. We got the critical value. We copied and pasted. So test statistic is larger, so we reject. So we rejected that they are not associated. So that means they are associated. Okay. We'll go next. So I'll close this. So we have part A. So we have a questionnaire, and we have 2 groups, and we have these 2 assumptions. If they're satisfied, we can do the test for independence. So it said here chi-square independence test, so you know that it's going to be contingency table. So what we're going to do is stat. So we're doing part A. Stat, tables, contingency, summary. So as we said, the numbers will go in the column, and the label with the words gonna be var1 here. And we'll click expected count, and we'll compute. So we have to check these 2, if they are satisfied or not. Then we can go with the test. So right here we have a warning that over 20% of the cells have an expected count less than 5. So that means this one is not satisfied. So are both assumptions satisfied? No.
How do you know if it's satisfied or no?
It will tell you right here.
Warning self 20.
Yeah, so this one is not satisfied, because it tells you a warning that over 20% of the cells have an expected count less than 5.
So it has to be 5 exactly?
No, so if it's satisfied, it won't give you the warning. But if it's not satisfied, it will give you the warning.
Okay. So warning, then
Yeah.
it's not satisfied.
Yeah, it's not satisfied. So this one is
Okay.
not satisfied, and this one, it is satisfied. Okay, so here is the expected frequency. They're all above 1, right?
Which one is satisfied?
The first one, this one, it's
A.
satisfied. Yeah,
Okay.
because the expected frequency is above 1. But the second one, we got an error. We have a warning.
Oh, this is
So
the second one now?
yeah, so are both assumptions satisfied? No, because this one, it's not satisfied. So we'll do D. So because one of them is not satisfied, we don't do the test. So we'll do this one. Independence test cannot be conducted. Okay, So if one of the assumptions is not satisfied, we will not do the independence test.
So it's all
Yeah.
the test cannot be concluded until B. B
Yeah,
is a
until
different
part B.
question.
Yeah, so we'll do
Okay.
part B. Yes. We'll do part B. Open StatCrunch. So we'll go to Stat, Tables, Contingency, Summary. So we have the numbers here and the label var1, and we'll check the expected count. So we don't have a warning here. So both are satisfied, they're all above 1. So yes, both are satisfied. So now we will do the hypothesis test. So because we're doing contingency, we don't test for equal proportions because that's in goodness of fit, and both conditions are satisfied, so we're not gonna do D either. So it's between A and C. So H0, the null hypothesis, is
So it's
always
A?
independent. Yeah.
Okay.
So with contingency, H0 is always going to be independent, and the alternative is going to be dependent. So here we have to do the test statistic value. So we'll copy. So 3 decimals, we'll put 1.
This is from the StatCrunch table contingency?
Yeah.
Okay.
So here we have the value. That is the test statistic. So next we have to find the critical value. So chi-square. We go to the right. We have 2 degrees of freedom. And our alpha is 0.01. So we'll put 0.01. So our test statistic is less than the critical value.
So
So
reject?
we fail to reject. You can
We
also,
failed.
yeah. So you can also compare the p-value, which is 0.02. It's larger than 0.01, so we fail to reject. So if we fail to reject the null hypothesis, what does it mean? So let's look. So H0 said that it's independent. So we failed to reject. That means the test could be independent. So we finished this question. Close this part. So here we have a one-way ANOVA. So let's find the degrees of freedom first for the treatment. So right here we have the formula. Okay, SS over this one is equal to MS. So we have these two given. We can find df on the calculator.
This work or calculator?
Yeah, so you'll use your calculator to find it.
1 second, I'll get it.
So the answer should be 2. And here we have the total, so we'll just add 2 on 26.
How did you get to?
So here we have the formula. So SS, when we divide by df, we'll get ms. So we have SS and ms. We can use them to find the degrees of freedom, df, for the treatment.
You said we divide SS by DF, but DF we still don't have it.
Yeah, but we have ms.
Yeah, so
yeah.
where is MS?
عمر حطه الكالكوليتر سوي شيفت سولف.
Yeah, you
لا
can do that. Yeah.
ما اعرف شو احط في الكالكوليتر.
Okay, just divide SS by ms.
This is MS.
Yeah,
we
so
divide it, I
divide.
get okay.
You get 2. So next we have to find the, look, so here we have these two, they are unknown. So we have to find ms. So how do we do that? So the F statistic the way that we get it is that we divide ms of the treatment over the ms of the error. So we have ms of the treatment and we have f statistic. So if we use the calculator, so I think we have it over here. Here. So this is the treatment divided by ms of the error, and then we get the f statistic of the treatment. So that's the formula. So this divided by this will give us this, okay? So this one is going to be 0.1.049.
Oh yeah, how did you get the 1.049? You divided which number by which number? Or which calculator?
So I divided ms over f statistic. We got
MS
this
over
one.
F statistic gives you the error for MS. Okay. And the total, oh, that one, that's addition. Okay.
Yeah. So now we have these two. We can find SS by using this formula. So 27.274, 3 decimals.
Which formula did you use?
This one, it's the same. So
So now we're dividing SS
uh,
by DF. Yes?
yeah, so SS by DF. So SS is unknown. So we'll divide DF over MS and we'll get SS that way.
Which one did you say to divide that 26 with the 1.049?
Yeah. So we'll get
Okay.
this part.
Okay.
So yeah, so now we have to find the total. So we'll add 27.274 plus 1.574.
Okay.
So here we have the total. So that's it. We got the total. And we finished with the question. So here we'll open the data and StatCrunch. So here we have analysis of variance. So that's ANOVA. So we'll go to stat ANOVA two-way because we have two variables, dorm and year. So responses with response. And here we'll row factor. So in row we have years and in column we have dorms. And we'll compute. So now we'll just fill in this table here. So year is 3, dorm is 3, interaction is 9, and we'll keep filling. So error is 16, and then we have 31 here. So next we do sum of square. So here we have the year first, so we'll put here 8.5. So next dorm 8.75. And then we have the interaction, and then the error, and then the sum. Then mean square, MS. So we'll put the year first. And then here we have the dorms. Yeah, be careful because they're switched. In the table, it's here, dorm. And here we have dorm and then year. So two
What did
decimals.
you say was switched?
Yeah, so over here with the calculation, we have year first and then dorm.
Yes.
And in the question, we have dorm and then year.
Oh, okay, okay.
So be careful not to put the wrong values. So we copy the interaction. 2 decimals, error, 2 decimals, so we round up. F statistic here, we put it here. So 2 decimals, and then dorms, 2 decimals, no rounding, and then interaction, and we're done with this part. 2 decimals, so we round up.
Can you show how you got the answers again? I saw the answers, but where did you go on the stat crunch?
So stat, ANOVA, two-way. So here it says analysis of variance. So that means ANOVA. And since we have 2 variables, that means it's two-way.
Oh, okay.
So what we'll do is, so responses is going to be with the numbers. Row factor, we'll open this one. Row factor is going to be here, the row we have here. So we'll do here. And the column factor we have here. The columns are dorms. So we'll do dorm and we'll compute. And we have the values.
Thank you.
So you're welcome. So here we have to test the null hypothesis for the dorms, okay? So we'll go here and we have the test statistic for dorm. We'll copy and we'll paste it. So next we have to find the critical value. So now we're using fstat. So we'll go to stat, calculator, and then F. So we'll go right. And since we're doing the dorm, so here we'll use numDF for the dorm df3. And then the then df is gonna be the error 16. Okay, so then we'll put alpha 0.05. So numDF is gonna be the dorm df because we're testing for dorm, and then df is gonna be the error df.
Can you repeat one more time? You kind of got lost.
Yeah, so what we're gonna do. So first of all, you have to check your test statistic. It's fstat. So what we're gonna do is stat, calculators, and then F. Okay, we're not using
Okay.
chi-square. If it said chi-square, we'll use chi-square.
It will
we
say
use-
chi-squared, yes?
Yeah, if it said chi-square, we'll use chi-square.
Okay.
If it said fstat, we'll use fstat. So because it's fstat, we'll go here. We'll go to the right side. And here we have the form dorms, okay? So what we're gonna do is numDF, we'll put dorm df, and then df is always gonna be the error, so 16. So now we put the alpha here, and we compute. So
okay.
So we got our critical value, and we'll
Okay.
put. So test statistic is less than critical value. So what do? We do not reject, right? So it's less, we fail to reject. And here we have the years. So we're testing for years. So we'll go here, look at here, copy it, copy and paste, and then critical value. So we have 3, and alpha is the same, 0.05. So we're going to use the same critical value and 2 decimals. Okay. So it's also less, so we fail to reject. So next we have the test null hypothesis of no interaction. So what we'll do is we'll go here. We have interaction, we'll copy it.
Is this recorded?
Yeah, it's recorded.
Okay.
So we're doing the interaction. So we copied the fstat. We rounded 2 decimals. Now we have to find the critical value. So we'll put 9 in degrees of freedom because we're doing interaction now. So we'll take the degrees of freedom, we'll put it here. And then df is going to be the error. So we'll click compute. So now we have this. We'll round to 2 decimals. So it's less than, so we fail to reject again.
Okay, doctor.
Yes,
Can you show how to find critical value in the table? It's given above the table. How to use the table? That one. Yes.
in the table. So I don't know why you would use the table because it's easier to use StatCrunch.
Okay, I'm just asking like if we have both options. If I know.
Honestly, I've never used the table before to calculate
Okay,
the critical value,
no
so I'm
problem.
not sure.
Okay, no problem.
So we finished with this part. The test statistic is less than the critical value, so we fail to reject. So we'll go to the next question. So here we have partially completed an ANOVA table for a 3x4 factorial experiment with 2 replications provided. So we have A, B, and AB. So A is going to be 3. So degrees of freedom is going to be 3 minus 1. So we'll put 2. And 4 is going to be B. So we'll put 4 minus 1, 3. And then AB is going to be 2 times 3, 6. So next, we need to find the error, df. So error df is going to be A times B times n minus 1. So it should be here, I think. This one. A times B times n minus 1. So we have AB, so what is n? N is going to be 2 because we have 2 replications. So what this 2 replication means that we have 2 samples in each.
What is n?
N is 2 because
It
it's
says
2
2.
replication. Yeah.
So 2 minus 1. Okay.
12.
So it will be
Will be 12. So now we have to find the total 23. So 2 plus 3 plus 6 plus 12.
wait, for the error 12, it's going to be 6. And then it's going to be 2 minus 1, yes?
It's gonna be 3 times 4 times 2 minus 1. So we
It
get
will be
12.
3 times 4, and then the brackets, what was it? 2 minus 1?
Yeah, 2 minus 1. So 2
To be
minus 1
2.
is 1, so you just put 12.
Oh, okay. Thank you.
So now we'll find SS of error. So we can just get the sum of this, and then we subtract from this. So 17.6 minus 0.6 plus 5.2 plus 9.3, all in parentheses. So we'll get 2.5. So if you want to check your answer, you can add these. And if you get this number, it's correct.
We get it the same way, yeah? What's it called?
The MS?
No, the error for SS. How did you get it again?
So the SS. So when you add all of these, you'll get this part. Since we
Yes.
since we don't know this part, we'll add all of these and then subtract from 17.6.
Okay, I understand.
And we'll get 2.5. So if you want to check your answer, you can add these 4. And if you get 17.6, it's correct.
Yes, thank you.
You're welcome. So MS. So if you remember the formula, it's SS over DF. So you'll use your calculator, put SS over DF. So MS is going to be 4 decimals. So on the calculator, we'll get 0.3. We don't have any other decimals, so we'll keep it like that. Next, we'll put 5.2 over 3, so we'll get 1.7333. So 4 decimals. So 9.3 divided by 6, we get 1.55, and then 2.5 over 12. So we get 0.2083, 4 decimals. So now f stat is going to be ms over error. So 0.3 over 0.2083. So 2 decimals. So we'll put 1.44. So the one next, we'll put this over this. We get 8.32. And then we'll put 1.55 over 0.2083. So we get 7.44. So we finished this part. So how do we get the sum of squares for the treatment? So we have variable 1, variable 2, the interaction, and then the error. So the treatment is going to be A plus B plus AB. So SSA, SSB, SSAB. Okay, next. Do the data provide sufficient evidence to indicate that the treatment means differs? So we'll go here. So we're testing for treatment mean. So H0 is going to be that there is no difference between the treatment means. So this one talks about response mean. We're not going to use it. This one only talks about A. This one only talks about B. So we're not going to use them. So we're going to use this one. H0, there's no difference. Because we have to do A and B. So if we see anything that talks strictly about one variable, it's automatically wrong. We're not going to use it. So H0, no differences exist among the treatment means. So what is the opposite? At least 2 are gonna differ. So next we have to find the test statistic for the treatment mean. So how do we do that? So first we have to find MS for the treatment. So we'll do 0.6 plus 5.2 plus 9.3, and then we'll divide it by the sum of DF. So divide by 2 plus 3 plus 6. So we'll get 1.3727. So we'll get that number, and then we'll divide it by the error, MS, 0.2083. So the test statistic is going to be 6.59. So we added SSA and SSB and SSAB. And then we divided the sum of SS over the sum of DF. So 2 plus 3 plus 6. And then the number that we got, we divided it by MS error. And that's how we got the test statistic.
Okay, so can you go back to the top? So you added the sum of the SS, yes?
Yeah, so yeah.
The first
SSA,
three?
B, AB. Yeah.
The first three, okay. And then you added the DF, the sum of the DF.
Yep.
Then you divided the sum of SS over DF, I think.
Yes, correct.
And then you divided the answer by the error of MS, yes?
Yeah.
Okay, that's how you get the, I think, F stat? Yes, F stat.
Yeah. So this is the
Okay.
F stat for the treatment. So let's get rid of this. Okay. So wait, we need StatCrunch. So yeah. So over here you don't have the table to find the what do you call the p-value. So you have to use StatCrunch. It's easier, it's faster. So we'll go to calculators, we'll go to F, we'll go to the right. So df, we're gonna put the df of error for then df, and then num df, we will put the sum for AB and AB. So 2 plus 3 plus 6, 11. And then we'll put F statistic over here. And this is our p-value. 3 decimals. So do we have an alpha here? 0.05. So we reject because it's less than. So we reject. So what did we reject? We rejected that there's no difference. That means at least 2 are going to be different. So we reject the data provides sufficient evidence to indicate that at least 2 means differ. So B. So here, because we found the 2 treatments are different, so that means we can test for if there's an interaction or not. So yes, so we have 2 yeses. So this one says the test does not indicate that differences exist. But this is wrong because we said there is a difference. So we'll take C. So there is a difference and we should test if there is an interaction or not. And if there is no interaction, we will do the main effect test. So 2 factors are said to interact if the effect of one factor on the response is not the same at different levels of the second factor. So if you change one part and the other part also changes, so there might be an interaction between them. So next. So what is the practical implication if factor interaction exists? So if there is an interaction, what do? We don't do the main effect test. Just right here, look. So if warranted, we'll use the main effect test. So if there is no interaction, we'll use the main effect test. If there is an interaction, we will not do the test. So your life will be easy. So now we'll do the null hypothesis and alternate for interaction with the response mean. So we have here factors A, B do not interact with the response mean. And then the opposite is going to be that they do interact. So what is the test statistic for the interaction? It's A times B, this one, AB. This is the interaction. So we'll take the F stat, we're going to copy it over here. So we need to find the p-value. So we'll close this. So stat, calculators, F stat. We'll take the right side and then df is going to be the error. So we'll put 12. Num df is going to be the interaction df, 6. And then we'll put F stat over here and we'll compute. So this is our p-value. Okay. We'll put it and then we'll round up 0.002. So it's less than, so we reject. So if we rejected the null hypothesis, that means there is an interaction. So there is sufficient evidence to indicate that 2 factors interact. So if we have an interaction, we said we don't have to test for the main effect. So do we need to do further testing? No, because they interact. No, since the test statistic indicate two factors interact, there's no need to test the main effects. And we finished with this question. So does anyone have any confusion we can go over? Okay, we'll go next. So here we have to perform a two-way ANOVA test. So what we're doing is we have to see if the gender and age affect the GPA. If the interaction affects the GPA. So we have to pick the main effect.
The one with the gender?
Yeah, so we'll pick gender and age. So which we said H0 has no effect. So gender has no effect on GPA. So now we have to find the age if they're with the GPA. So B. So gender doesn't affect the GPA and age doesn't affect the GPA. So here we have to do the null and alternate hypothesis. So it's gonna have the same words that we chose here. So their interaction between age and gender, yeah, has no effect on GPA. This one. So age, no effect, and gender is no effect. So now we have to do the test statistic. So we'll go to StatCrunch, ANOVA, two-way. So responses is gonna be GPA. Row factor, we have gender. Column factor, we have age. And we'll compute. So we're testing for the main effect, which is age and gender. So age and gender, wait, this is GPA and gender. So this is wrong. Age and GPA, it's also wrong. We're doing age and gender. So here, age. So age is gonna be column factor. So our test statistic is this one. And we do 2 decimals. So this becomes 7. And then we do gender. We'll take fstat, copy and paste. And we'll round 3 to 4. And now we need to find the test statistic for the interaction. It's here. We'll copy. So we round up. So 9 will carry. This becomes 10. So next, p-value. So age and gender and age and GPA, no. Age and gender and GPA. This is correct. So here it's the p-value. So p-value for age is gonna be this one. Copy. So 3 decimals. And then p-value for gender. Gonna copy and paste. We'll round up. So next p-value for the interaction. This one. So we'll round. So now, should we reject the null hypothesis for one of the main effects? So it's either age or gender, we reject one of them, or we reject both of them, or reject all of them, or we only reject the interaction. So what do? We have alpha here. We'll compare. So age is larger, so we fail to reject age. Gender. So gender is also larger, so we fail to reject age and gender. And interaction is also larger, so we fail to reject all of them. So C. Wait, no, it's E. failed to reject. So if we fail to reject, what does that mean? So if you remember, we said the null hypothesis has no effect.
So it does have an effect if you fail to reject the claim.
So here we have H0 has no effect, so we fail to reject it. So gender has no effect, and age has no effect on GPA.
What was the original claim from the?
You have to choose. It doesn't say anything here.
Oh.
So we have gender has no effect on GPA, and age has no effect on GPA. So this is the result. So now we have to interpret the result for the interaction. So what we said was we failed to reject this part, so the interaction between age and gender has no effect on GPA. So the interaction between age and gender has no effect. This part, B. So we finished with this question. We'll go next. So we'll open the data. And over here, let's see. So we're testing the claim that 3 samples from population have the same mean. So they have the same mean. So H0 is going to be equal. So D and B are wrong. So H1 is going to be like, at least one is going to be different. So C. So we open the data and StatCrunch. We go to Stat, ANOVA, one way. We'll select all of them and we compute. So we'll take fstat, we'll put it here, round to 2 decimals, so we'll round up. P-value, it's 0, so we'll put 0. So we rejected, so we have sufficient evidence to warrant rejection that the 3 different states have the same mean arsenic content. So given that the amounts of arsenic in the samples from Texas have the highest mean, can we conclude that brown rice from Texas poses the greatest health problems? So so it said that Texas has the highest mean. Does that mean that Texas has the highest health problems? So ANOVA doesn't actually tell us how different they are. It only tells us that they're not the same. So the result cannot conclude that Texas has the highest health problems. Because with ANOVA, we only test if they're the same or not. So we don't know how different they are. Maybe like 2 of them are equal and 1 is different. Maybe they're all different, so we don't know. So C. So we'll open StatCrunch. So here, we're testing for an interaction. So we're testing an interaction between gender and handiness. So H0 is going to be no interaction, and H1 is going to be interaction. And these two are automatically wrong because there's only one variable. There's no interaction. So we'll do StatCrunch now. So we'll name var4 rows, var5 is going to be columns, and var6 is going to be responses. So we'll copy female. We'll paste the gender in rows. So we'll paste it twice. We'll copy male. We'll paste it twice. And for columns, we're gonna do the column factor, which is handedness. So we have 5 females. So we go 5 here, paste right hand, 5 left hand as well, and we'll copy it and do the same thing for male. And then we'll copy the values for right hand. We'll copy the left hand values for female. We'll put it here for female left hand. We'll do the same thing for male right hand and the values for male left hand. So we're done. So we'll go to ANOVA two-way responses, and row is going to be rows and column with columns. So test statistic, we'll go for the interaction. So 2 decimals, we'll round up. And then we have the p-value. 3 decimals, we round up. So p-value is greater than 0.05, so we fail to reject the null hypothesis, which says that there is no interaction. So fail to reject, there is insufficient evidence to support the alternative hypothesis, so there is no interaction.
Mahmoud, can I ask you, when do we need to use this method where we copy paste and organize the stat crunch?
You're gonna use it when you do ANOVA two-way.
ANOVA two-way? How do I know
Yeah.
that?
When it says you have to test for interaction.
Testing for interaction is ANOVA two-way?
Yes.
Okay.
So next we have to do the error factor. So what do? We'll open this one. We see that gender is the row factor. So this one talks about left hand, right hand. So A, B, and are wrong. So C and D. We have to choose one of them. So H0 is the same. This one is correct. So now test statistic for the row factor. Go here, copy the row factor, and we'll put 2 decimals. And then we'll put p-value 0. So we rejected the null hypothesis. So we have to reject. This one talks about handedness. It's wrong because we're doing row factor. It's about gender. So C. So next is column factor. It's handedness. So B and C are wrong. We have to choose between A and D. So H0 is going to be the same population. So we'll go with A. So here we have the test statistic for column. We'll copy the F statistic, we'll put, and we'll round to 2 decimals. And next we have the p-value. We'll round up to 3. So p-value is bigger than 0.05. What does that mean? We failed to reject. And there is no sufficient evidence, so handedness does not appear. A is correct. So we finished with this question. We'll go to 12. So here we have another two-way ANOVA question. So we're doing the interaction between 2 factors. So gender and smoking. So we said H0, no interaction, and H1, there's an interaction. So D. And we go here, we have to do rows, columns, and then
Mahmoud?
responses. Yes?
I don't think you have to repeat this question because Dr. Jaya said that we don't have to do any question that has copy paste since lockdown doesn't allow us copy paste. So she will give us questions that already has the data entered.
Okay, so I'm gonna just put the data myself, and we'll
Okay.
just do the steps and the hypothetical questions.
Okay.
Just for the sake of the hypothetical and theoretical questions.
Can I just ask again how you found out the multiple choice, H0, H1?
Yeah, we'll do it after,
After
reading
you
this.
finish this one, okay.
Okay, so we'll go to stat ANOVA, two-way, responses with responses, rows with rows, and column with column. So here, so we're doing an interaction between two factors. So this one only talks about one variable, not two variables, so it's wrong. The same, this is wrong as well, because we're doing two factors. So we have to choose between C and D. So when we're doing interactions, H0, the null, is going to be are not affected by interactions. So yeah.
Okay, thank you.
So yeah. So H0 there is no interaction, and H1 there is an interaction. Okay. You're welcome. So next we'll do the test statistic for the interaction. We'll copy and paste fstat, and we'll put two decimals. So this will become 6, and we'll copy the p-value. So this will become 1. So p-value is bigger than alpha, 0.05. So we fail to reject, and there is no interaction. So next we have to test for gender. So this is not gender. So B and C, we have to choose one. So H0, men and women have the same mean body temperature. So B is correct. So gender is 0. So we'll go to StatCrunch, we'll copy row factor of stat, and we'll put two decimals. We'll go to p-value, copy, round up to 3 decimals. So this becomes 7. So p-value is bigger than alpha, which is 0.05. So we failed to reject, and we're talking about gender, so this one, A. So next we have to test for smoking. So we have to choose our hypothesis, so A and C. So here we have smokers and non-smokers have the same population mean body temperature. So A is correct. So H0 is going to be the same mean, and H1 is going to be different. So this is the same as, I think, chapter 8 or chapter 9. So here we have the test statistic for columns. We're going to copy it, and we'll round up to 2 decimals. So this becomes 7. And then we have next the p-value. We'll copy it, and we'll round up to 3 decimals. So p-value is bigger than alpha, so we fail to reject. This one talks about gender, but we're doing columns, so this is wrong. We'll do B, because we're doing smoking. Yeah, that's it. We finished with this question. Close this part. So here we have an author, and he argues that baseball players have birth dates in the months immediately following July 31. So we're testing that baseball players are born in different months with the same frequency. So this is our claim, not the author's claim. This is the claim, this part right here. So H0 is going to be the same frequency, and H1 is going to be at least 1 is different. So here we have H0 as at least 1 is different. These two are wrong. And D, H1 is not the same as our claim. It has to be similar. So H1 is here we have A is correct. So we're testing for frequency. So we'll use goodness of fit. So goodness of fit chi-square. Here is our observed data birth. And so we're testing if they're equal or not. So we'll do all cells in equal proportion. And here we have the chi-square stat. And we round up to 2 decimals, round down because it was 3. So next we'll copy p-value, it's 0. So 0 is less than alpha, 0.05. So we reject the null hypothesis. That means we'd have sufficient evidence to warrant rejection of the claim that they're all born with the same frequency. So that means at least one is different. So that means the
Can I ask, how did you find the test statistic again?
so
Yes.
we're testing for frequency, if they're equal or not. So frequency, we go to goodness of fit, chi-square. We'll take birth as our observed data. And since we're testing if they're equal or not, we'll do all cells in equal proportion.
Oh, okay.
So we copied chi-square, we rounded 2 decimals, and we put the p-value 0. It's less than alpha, so reject. So we have sufficient evidence that they are not born with the same frequency. So that means that the author might be correct. Because the author said that they are not equal in frequency. So let's open this part. So null hypothesis, we have same frequency. Wait here. Where is it? Same frequency. And here at least one is going to be different for the alternative. So what we'll do is stat. So they gave us the data. We have to find the frequency. So we will go to tables, frequency, and we'll choose this, go down, and store it. So here we have the frequency. So we're testing if they're equal. So we'll go to stat, goodness of fit, chi-square. So we'll take frequency, our observed data, and we'll do all cells in equal proportion. We'll copy chi-square, and we'll do p-value as well. We'll round up to 3 decimals. So p-value is bigger than 0.01, so we fail to reject. So there is no sufficient evidence to support the claim that. So what is our claim? Here. Births do not occur on the 7 days of the week with equal frequency. So this one. So make sure that the claim is the same as here. So we're done with this part. Now we have the final question. We'll open StatCrunch. So we are testing for contingency table. So we have R1, R2, C1, C2, C3. So we are testing if the rows and columns are independent or not. So B. We'll go to stat, tables, contingency, summary, and we said for columns we choose with the values. So C1, C2, C3, and row label with the words here. And we'll do expected count because they want expected frequency. So we'll copy the expected count for C1, we'll copy the expected count for C2, C3, Okay. So next, the chi-square test statistic. So we have it here, the value. So round to 2 decimals. And then p-value, 3 decimals. So p-value is larger than alpha. So we fail to reject or do not reject. So we don't have evidence that they are not independent. Okay. Should we submit?
يلا
Does
بسم الله.
anyone have any questions?
Not really. We could just review the recording later
Okay.
and practice. ما شاء الله.
So if you follow the steps, you're gonna get a full mark.
والله I was sure